In this video, we will teach you the basic concepts of population and samples. A population is a group of individuals who have something in common. Since it is very hard to get information for every individual of the whole population, we have to take samples, which is a part of the target population. A sample is a small group of the population representing the population, hence, it has to be randomly selected. This process is called random sampling. In this video, we will first introduce random sampling. Then, we will talk about the differences in parameters and statistics, and the concept of degrees of freedom. Okay, let's start with the basic concepts of random sampling. There are two kinds of sampling, namely, with replacement or without replacement, depending on whether selected individuals are put back into the population before the next selection. In sampling without replacement, the first individual is randomly selected from the whole population. The next individual will be selected without putting the previous individual back. Every individual is selected from a different pool. The other kind of sampling method is sampling with replacement. The individual will be put back before the next individual is selected. Hence, it is possible that the same individual will be selected multiple times. In this example, we first create a blank data frame and we create a new population column in this data frame with some data. We then draw 5 individuals randomly without replacement, and stored them as sample no replacement. We use method samples to get samples. Here, the argument replaces equals false means the sampling is sampling without replacement. We can replace the argument by true to perform sampling with replacement. You can see that for sampling without replacement, there are no duplicates of individuals or indexes. However, for sampling with replacement, it is possible to see the same individual is drawn multiple times. Mean and variance of the population are characteristics of the population. Once target populations are fixed, these summary numbers will not change. We call them parameters. Samples also have mean and variance, but their values change when we take different samples, even if they are drawn from the same population. We call them statistics. We can calculate the mean and variance, using data frame methods, mean and var. In calculating variance, we set the keyword DDOF as 0, meaning the denominator of the population variance is n. First, let's get a sample with size 10 from the population, using replacement. The sample variance is printed out. Notice that when we compute a sample variance, we need the DDOF equal to 1, it means the denominator of a sample variance has to be n1 instead of n, which is the sample size. It gives an unbiased answer. To understand why the denominator of the sample variance is n1, let us generate 600 samples, each sample with a size equal to 10. We calculate sample variance for each sample using n and n1 as denominators. You'll find that the real population variance is 385. As you can see, the average of sample variances using n1 is closer to population variance than using n. The average of sample variance using n as the denominator, DDOF equals 0, is always smaller than population variance, which is 385, which is some mathematical reasons. In fact, this is related to a concept called degrees of freedom. For sample variance, there is another explanation why sample variance is divided by n1, which is the degrees of freedom. Degrees of freedom is the number of values, used in the calculation, that is free to vary it. When we use the sample mean to compute the sample variance, we will lose 1 degree of freedom in our calculation. For example, we take the sample size to be 10, the sample mean equal to a certain number is used in computing sample variance. We can choose 9 numbers independently for the sample, the 10th is not free to vary it because of the constraint of the sample mean. There is only one choice. When we compute the variance, using degrees of freedom is better than using the sample size, in the sense that it is an unbiased estimator, meaning that the average of the estimator will be equal to population variance. Great! In this video, you have learned a lot about population and sample, including random sampling, parameters and statistics, as well as degrees of freedom. In the next video, we will move on to talk about the distribution of sample statistics. See you in the next video.